Computing the exact values of trig functions. So what we want to do first, we want to find the exact values of the trig functions for the angle pi force, which is the same as 45 degrees. So what I want to do first, I want to draw a right triangle. And that's definitely not a right triangle, but we want to draw one. Now, on this right triangle, do you know that these two angles are both 45 degrees? Since we're saying that pi force is, or 45 degrees is the angle we're considering, which means, and the reason why we know it's 45 each is because if you add up all the measures of a triangle, it always equals 180 degrees, the angle measures, that is. If this is 90, then these two add together must be 90. Since we said one of them is 45, the other one must be 45. And since these two angles are the same, that means that the angles, or the sides that correspond, or that are opposite those angles, are the same. So we're just going to call those x, each of those x. And then we're going to call this, the hypotenuse, c. And then we're going to use the Pythagorean Theorem, and if you remember that, a squared plus b squared equals c squared. Now our a and b are the legs, which are the sides that are adjacent to the right angle, which in this case both of those are x. So we now have x squared plus x squared equals c squared. And this is the same as 1x squared plus 1x squared, which is 2x squared equals c squared. What I'm really doing is I'm trying to find a value for c. And to do that, because I need to know what that side actually is with respect to x, that's what we're trying to find. In order to solve this, for c, I take the square root. Now normally it's positive and negative, but since we're dealing with the side of a triangle, we're only going to use the positive value, so it's going to be positive. And then we're going to assume that x is also positive, so the square root of 2 stays underneath, or 2 stays underneath the square root, and the square root of x squared, the exponent and the index cancel each other out, if you want to say it like that. And the x is on the outside. Normally I'll put it on the back side, but I'm going to put it on the front so you won't be confused with it. And so what that now means is that we have c is equal to x square root of 2. Now I'm going to erase some of this in here so we can make it a little bit easier to see. So now I'm going to just look at this angle, or this angle. We'll call this one once again 45 degrees. It doesn't matter which one you want to look at, but I want to look at that one. And I'm actually now going to find the sine of 45 degrees, or sine of pi half, or pi force, I mean. Either way you want to look at it. Now once again, sine of 45, if you've been watching other videos I may have made, or other people's videos, hopefully you know by now that the sine of 45 is the same as the opposite over the hypotenuse. If this is the angle we're looking at, sine of 45, or 45, the side opposite of that is this x over here, so that's our numerator, over the hypotenuse, which we just found is x square root of 2. And that's the same as, these x's cancel out, 1 over square root of 2. And we don't like radicals in the denominator, so we're going to rationalize. So we're going to multiply top and bottom by square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is the square root of 4, which is a regular 2. So the sine of 45 is a square root of 2. Now based on that fact alone, and other information that we've just studied about sine, cosine, tangent, cosecant, secant, and cotangent, we can now find all the values for sine, cosine, tangent, secant, cosecant, cotangent of 45 degrees. That's what we're going to do. Since 45 and 45 are complementary, that means that the cofunctions are equal. Cofunctions of complementary angles are equal. That means that cosine of 45 degrees is also the square root of 2 over 2, or it's the same as x over x squared root of 2. and then it's the exact same process as we used here. And now let's do the tangent of 45. And since tangent is the same as sine over cosine, we're going to take square root of 2 over 2, which is sine of 45, over square root of 2 over 2. And if you want to, put that in parentheses just so you know we're taking the same thing divided by itself, which is 1. And actually I have the table that has all of this. I'm going to go ahead and find, well, cotangent's really easy, because tangent of 45 is the same as the cotangent of 45, because they're cofunctions of complementary angles. It also equals 1. And the only other question we really need to worry about is how to find cosecant and secant. Well, let me go up here and erase. Let me erase this, so we can find cosecant and secant pretty quickly. And these are values that you really want to learn, memorize, especially if you plan on taking calculus. And I'll show you how to memorize a lot of this. So to find cosecant of 45, cosecant is the same as 1 over sine, so this is the same as 1 over sine 45 degrees. So this would be the same as 1 over square root 2 over 2. If you know anything about complex fractions or how to divide fractions, you know that's going to end up being 2 square root of 2. We don't like radicals in the bottom, so we multiply by the bottom, top and bottom, by the same thing. We get 2 square root of 2, and square root 2 times square root 2 is square root of 4, which is 2, and those 2's cancel, leaving the square root of 2. So the cosecant of 45 is the square root of 2, and since cosecant and secant are cofunctions and 45 degrees are complementary, they equal the same value, square root of 2. Now let's find the exact values of trig functions for 30 degrees and 60 degrees. Now to do that, I'm going to draw an equilateral equiangular triangle, which means that all three angles are 60 degrees, because they must add up to 180 degrees, and they're all the same. That means they're all 60 degrees. And then if one side is x, all three sides are x. What I want to do is cut that in half, which means I have a right triangle, which means that this 60-degree angle has been cut in half. So I only need half of it, which is 30 degrees. And then I don't need the other part of this triangle. And it also means that this side down here is not x, it's x over 2, because we're only going to use half of it. So this is the triangle we're going to look at. And before we do that, we need to find this missing side, so we'll call it B. And to find that missing side of the right triangle, we're going to use the Pythagorean Theorem once again. And that is, once again, a plus b squared equals c squared. Now we're going to call a squared this half side, which is x over 2 squared. We're going to leave b as b, and c is the hypotenuse, which we called x. So when we multiply out x over 2 squared, that's x times x, which is x squared, and 2 times 2, which is 4. Remember, we're solving for b. So I want to subtract off x squared over 4 from both sides. And we end up with b squared equals, now I'm going to put that over 1, x squared over 1 minus x squared over 4. We need LCDs, which is going to be 4. So we're going to multiply top and bottom by 4. And so that looks ugly. Let me clean that up just a little bit. It's x squared times 4. So that becomes 4x squared minus x squared, which is the same as 1x squared over 4. And 4 minus 1 is 3x squared over 4. And what I want to do now is get rid of the exponent. And the way we do that is, I just want to write it down first, make it a little bit cleaner, is the square root of both sides. Once again, since we're dealing with the side of a triangle, we'll only worry about the positive side. And we're going to get b equals, now watch this, the 3 stays underneath the square root. The square root of 4 is 2, and the square root of x squared is x. So what that means is we have this as our triangle. This was the 30-degree angle. This was the 60-degree angle. This side was x. This side is now square root of 3 over 2 x, and this was x over 2. So we did all this work to find these three sides. So now we can find our angle measures. So let's find sine of 30. In fact, if I find sine of 30 and cosine of 30, I have enough information to find everything. So let's find sine of 30. Sine of 30 is the same as opposite over hypotenuse. So we're going to have x over 2 divided by x, which is the same as x divided by 2. I'm going to do all the work so you don't know. Divided by this x on the bottom, or same as x over 1. And then you multiply by the reciprocal. These x's cancel, and we're left with 1/2. Sine of 30 degrees, or the sine of pi 6, is 1/2. Now I'm going to find the cosine of 30. Cosine of 30 is the adjacent over the hypotenuse, so it's going to be square root of 3 over 2x divided by the hypotenuse, which is x, and these x's cancel, leaving square root of 3 over 2. Now from there we can do all kinds of things. Sine of 30 is the same as the cosine of 60, and that's what you're going to see down here. Sine of 30 is equal to cosine of 60. Cosine of 30 is the same as the sine of 60. And all we need to really do now is find the tangent of 30 and the tangent of 60. Let me show you how to get all these values. And there's a couple ways you can do it. There's several ways you can do it, really. You can still use this triangle, or you can use your sine and cosine. What I'm going to do, I'm just going to use sine and cosine. So let's just go ahead and find tangent of 30. That's the same as sine of 30 over cosine of 30. Once again, when you know sine and cosine, you really know everything. Sine of 30 is 1/2. And cosine of 30 is square root of 3 over 2. And what's going to happen is these 2's are going to cancel, leaving us with 1 over square root of 3. I do not like square root of 3 on the bottom, so I'm going to multiply by the square root of 3. And we get the square root of 3 over square root of 3 times square root of 3 is square root of 9, which is 3. So that's how we get tangent of 30 square root of 3 over 3. Now this cosecant of 30 is the same as 1 over sine, and 1 over 1/2 is 2. Secant of 30 is the same as 1 over square root of 3 over 2, which is the same as 2 over square root of 3. And anytime you get 2 over square root of 3, once again you need to rationalize. So we're going to multiply. And we get 2 square root of 3, and square root of 3 times square root of 3 is square root of 9, which is 3, and that's where that comes from. Cotangent of 30 is the reciprocal of square root of 3 over 3. So if you stack 3 over square root of 3, then if you just flip it over And once again, you have to multiply. I'm just doing this to save a little bit of time. So we have 3 square root of 3 over 3, and these 3's cancel, leaving the square root of 3. Once you have all of this, you have all of this. Sine of 30, same as cosine of 60. Cosine of 30, same as sine of 60. Tangent of 30, same as cotangent of 60. Cosecant of 30 is the same as secant of 60. Secant of 30 is the same as cosecant of 60. Remember, cofunctions and complementary angles. I may have been saying supplementary. It's complementary. And then cotangent of 30 is equal to tangent of 60. Or, if you know cosine 30, or sine of 30 and cosine of 30, you know it all. In fact, I'm going to narrow it down even more of everything I've just been talking about. When I was taught trig back in high school, I had an excellent trig teacher. Excellent. And here's one thing that she made us memorize, and it's something that you can't go wrong with. Especially if you're going to be taking calculus or you're going to major in math. So as I make these videos, I'm going to point out things to help you memorize. And the more you memorize, the better you're going to, the quicker you're going to be to finish. And here's one thing you have to know. Sine of 30, sine of 45, sine of 60. And it's worth memorizing these. Watch this. 1, 2, 3. And they're all over 2. It just so happens square 45 and sine of 45 and sine of 60 have square roots. Sine of 30 is 1/2. Cosine of 30 is square root 3 over 2. And we just found earlier that sine of 45 is square root 2 over 2. In fact, if you know that, you know everything, because sine of 30 is the same as cosine of 60. Sine of 45 is the same as cosine of 45. And sine of 60 is the same as cosine of 30. So that means we automatically know sine 30, 45, 60 and cosine 30, 45, and 60 just for knowing sine 30, 45, and 60. I'm telling you, it's really, really beneficial to you. Now let's do some examples. Function value, you're going to find f of theta over 2 if f of theta equals sine of theta and theta equals 60. Well, what all that means is f of theta over 2, well, theta is 60, so that's the same as 60 over 2, 60 degrees. And 60 degrees divided by 2 is f of 30 degrees. So all that means you're going to do is everywhere you see a sine of theta, that theta is now 30 degrees. And what is the sine of 30 degrees? One of those things you should memorize. It's 1/2. And we still do have the charts. I'm just telling you. Let's find 4 cosine 45 degrees minus 2 sine of 45 degrees. And there's a couple ways of doing this. I'm going to do the long way. Cosine of 45 degrees is square root 2 over 2 minus 2. And sine 45 is also square root 2 over 2. And then this 2 goes in this 4 2 times, leaving 2 square root of 2. These 2's cancel, leaving 1 square root of 2. And 2 square root of 2 minus 1 square root of 2 is 1 square root of 2, or just plain square root of 2. Now let's do this one. 6 tangent of 45 minus 8 cosine of 60. Now here's the way I'm going to do it by memorization. 6 stays 6, and that's 6 times, just like that's 4 times. So I'm going to put these parentheses. Tangent of 45 is the same as sine of 45 over cosine of 45. Well, sine of 45 is a square root of 2 over 2. And cosine of 45 is square root of 2 over 2. Which basically means that anything divided by itself is 1. And then minus 8 times cosine of 60. Cosine of 60 is the same as sine of 30, and sine of 30 is 1/2. So now I have 6 minus 8 times a half is 4. So 6 minus 4 is 2. I didn't look at anything. It's all memorization. Just because I know sine 30, cosine 30, well, sine 30, sine 45, and sine 60, I can find everything else. And we've been doing a lot of this information, and I've been doing a lot in my head. So there may be other ways of doing this. And yes, there may be a calculator way. And that's what we're going to do now. We're going to use our calculator to find some trig values. So let's go ahead and look at a calculator. And the first thing you're going to notice with the calculator is it has a sine, cosine, and a tangent. See that? Sine, cosine, tangent. Now here's how you're going to do. First off, look at this example. We're going to approximate sine 28 degrees to 2 decimal places. Notice that the 28 is in degrees, so I want to go to mode and make sure that it's in degrees. That's the first thing. So now I'm going to hit sine and just type in 28, close parentheses, enter, and I get my answer. We're going around to 2 decimal places, so it's 0.47. Now you may be wondering, how do I know that's correct? Well, we know what the sine of 30 is, don't we? It's 1/2. So let's just go ahead and type in sine of 30 just to check. 0.5, which is the same as 1/2. So we know we're doing it correctly then. Now, and that's how you do all of those, sine, cosine, tangent. But we also have cosecant, secant, and cotangent. So, how do you find those? Well, let's look at our calculator again. We'll move it over here. And we don't see a secant or a cosecant or a cotangent because we don't have one. So we have to remember what we know. We know that cotangent is the same as 1 over tangent. And so there's 2 ways we can do this. We can go ahead and find 1 over tangent of pi nines. And that's the way I prefer to do it. I prefer to use the trig information. Now to do that, notice that it's pi ninths. That's radians. Anytime you don't see the degree symbol, it's assumed to be in radians. So we won't go to mode. We go down and hit enter to convert it back to radians. So now I'm going to type in tangent. I'm going to put the pi ninths, second, caret key, divided by 9 in parentheses. It's not really what I wanted to do. I want to put in 1 divided by tangent of pi ninths. And if you round to 2 decimal places, we get 2.75. I should be using squigglies. These are only approximations. Now there's another way. This is what I was thinking before. If you type in tangent, pi ninths, pi divided by 9. Over here it's in x negative 1. That's the inverse key. Cotangent is inverse of tangent. So if I hit that inverse key, then enter, it also gives us the correct value. So either way. Now let's find this value, this example. We're going to find f of pi 6. And now this time it wants it as a single fraction, which means I can't use my calculator. So I want to use, maybe I can, maybe a nice answer, but it may not be. So let's do it by hand first. So f of pi 6 just means everywhere we see a theta, we're going to put pi 6. Now, pi 6, if you remember, pi 6 is the same as 30 degrees. And all I'm really doing is I'm just taking 6 into 180. And so sine of 30, or sine of pi 6, is 1/2. And then this over here, 2 times pi 6 becomes pi thirds, because the 2 goes in 6 3 times, leaving 3 on the bottom. And these 2's cancel, leaving a 1. And then what is the sine of pi thirds? Well, remember, here's what I like to do. Pi thirds is the same as 60 degrees. And the sine of 60 is the square root of 3 over 2. And then we need common denominators. So 1 over 1, we multiply by 2, because that's our LCD, which is 2. So we get 2 over 2 minus square 3 over 2, which is 2 minus square 3 over 2. That's a fun one, wasn't it? Now, I can't use a calculator to find this answer because of the ugly answer, but what I could have done, this. I could have found sine of pi 6. Remember, these are in radian mode, or in radian, so I'll make sure I'm in radian mode. So I could have found 2 sine of pi 6. But even then, you have to be careful, because I can't find the sine of pi thirds, because it's an ugly square root answer. So, and the moral of the story is, don't use your calculator. Unless you absolutely have to, or if it says around to so many decimal places. Now we do have a couple more problems we're going to do. And the main thing is on this that you may or may not know. Well, there's some things. Sum of the triangle, the angles of the triangle is 180 degrees. The area of the triangle is 1/2 base times height. There's some other geometry formulas. Your book may have an appendix that you may want to look at. But the angle of elevation, the angle of depression are probably something new for you. Angle of elevation, it says measured upward from the horizontal to the line of sight. So let's say that you're looking horizontally, or your line of sight is horizontally, and you're going to look upward because your view is elevated. Well, this is the angle of elevation. Now let's say that your line of sight, once again, is horizontal, but you're going to look downward. Well, that's the angle of depression. So this is the angle of elevation, and this is the angle of depression. So let's see if we can answer a couple problems. We need some space. Probably should have been doing this the whole time, but that's okay. We have a 20-foot extension ladder leaning against a building. So let's draw a building. It's a really narrow building, so not the Leaning Tower of Pisa. So we got a 20-foot extension ladder. So here's our ladder. And this is their building. The ladder is 20 feet. That's definitely not a 20. That's a 12. And it makes an angle with the ground. So here's our angle. The ladder does. How far up the building does the ladder touch? So we want to know x. And our angle, we're told, is 62 degrees. So let's look at what we have here. We're given an angle of 62 degrees. And we're given this side of the triangle and this side. And this is a right angle, by the way, that the ground makes with the bottom of the building. So if you look at this angle, this side is the opposite and this side is the hypotenuse. Well, what do we know is the opposite of hypotenuse? Sine of theta. So that's what we're going to use, sine of theta. So we're going to use sine of 62 degrees is equal to the opposite, which is x, over 20 feet, because that's our hypotenuse. And this is the equation we're going to use. Now, to solve this, let me erase that, make it a little bit better to see. To solve this, we're going to solve for x, and to do that, we're going to multiply both sides by the LCD, or the only denominator in this case, which is 20. So when we do that, these 20s cancel out, and we're going to end up with x equals 20 sine 62 degrees, which we're going to approximate that with our calculator. Sine 62. Since it is in degrees, I gotta make sure that my mode is correct. Now it is. Enter. And we get about 17.67 feet. So draw a picture and look at what you're given. See if you can find a sine relationship, or cosine, or tangent, whatever it may be. Now let's do this example. This one involves the angle of elevation. So we have a tree. Let's draw a tree. It's a really narrow tree, a really skinny tree. It's a 40-foot tree. Well, no. Make sure you read the problem. It's just a tree. It's going to cast a 40-foot shadow. So imagine the sun is up here, and it's casting a shadow on the tree. And that shadow is 40 feet. So this is the shadow. We want to know how tall a tree is, so we call it x. If the angle of elevation of the sun is 51.34 degrees. Now the angle of elevation is, when we look up, for our line of sight, so imagine you're the person, and this is your horizontal line of sight. The angle up is the angle of elevation, so that angle is 51.34 degrees. And this is a right triangle, once again. So we want to find x. So this is our angle. This side is opposite. This side is adjacent. And what is opposite of adjacent? That's a tangent. So that's what we're going to use. We're going to find tangent of 51.34 degrees. That equals the opposite over the adjacent, which is x over 40. And then, like we did in the other example, we're going to solve for x by multiplying both sides by 40. And we get x equals 40 tangent of 51.34 degrees. And so that's approximately, make sure our mode is in the correct form, degree still. So we're going to type in 40 tangent 51.34. Now I don't have to put the degree symbol because I'm already in degree mode, so that number is considered a degree. Enter. 49.99, we're going to call that 50 feet. So the building, or the tree, is 50 feet tall, approximately.